Mr. Alexander here, and today I want to teach you how to complete the square to graph quadratic equations. What we have are a bunch of equations that are in standard form that we want to convert into vertex form so that we can state the vertex, the axis of symmetry, the direction that it opens, and the domain and range. I'm going to try and do 3 of these for you. And I want to start on number 4 here. X squared minus 6x equals y. So the first thing that I like to do is I like to put in parentheses this x squared minus 6x, and I like to put plus a blank like that. Now there's no constant out here, so I don't need to write anything on the outside of the parentheses. But since I'm adding something here, in order to keep this equation level so that I don't change it, whatever I add in here, I'm going to have to subtract out here. So the number that I'm going to write right here is going to come from this negative 6. I should do negative 6 divided by 2. Negative 6 divided by 2 is negative 3. Then I want you to square that. Negative 3 times negative 3 is positive 9. Now I said I don't want to change anything in this equation, so if I add a 9 here, I'm going to need to subtract 9 out here. Alright? Now right here, this is called a perfect square trinomial. And perfect square trinomials are pretty nice because what I can do when I factor them is I can write x, and then I take half of negative 6. So x minus 3, because negative 3 is half negative 6. And I can write a square out there. This x minus 3 squared is the same as this x squared minus 6x plus 9. That's the nice property there. And I still have this negative 9 out here. Well, hopefully you recognize this as vertex form. So I can write the vertex. And remember, inside the parentheses is counterintuitive, so that's a positive 3. And outside the parentheses is just regular, so that's a negative 9. So 3, negative 9 is the vertex. Now the axis of symmetry, I'm just going to write AOS. That's going to be a line x equals. It's always x equals something. And it's just x equals whatever the x in the vertex is. X equals 3. Now the way to know if it opens upwards or downwards, it's going to be right here in the front of the vertex equation. If there's a negative, it opens downwards. There's no negative, so this thing opens upwards. I'm just going to put a little arrow. It opens upwards. So domain and range. Up here at the top it says for problems 1 through 4, use inequalities for the domain and range. Okay, so the domain, I'm just going to use big D. Well, the domain is the same for every quadratic. It's just negative infinity less than x less than positive infinity. The range is what's going to change. And the lowest y here is negative 9. So negative 9. And then it goes up forever. So y is greater than or equal to negative 9. Now I'm supposed to graph that as well. So in this graph over here, number 4, I'm going to go ahead and plot the vertex, which is 3, negative 9. And I know it goes up. Since it's a quadratic and there's no number in front here, it means I go up 1 over 1. And then to get the next set of points, you go up 2 over 1. And from there, you should be able to draw this nice, smooth quadratic function. Like that. So up 1 over 1, then up 2 over 1. That's how you're going to get the points for this quadratic. All right, I want to flip over to the back now. And I want to look at number 6 here. because now we've got a negative. So the process is exactly the same. I want to factor out the negative first, though. And I want to keep that plus 1 on the outside. So if I factor out the negative, then inside here I've just got an x squared. And I don't have a 2x anymore, because I factor out a negative, so that's going to have to become a negative 2x. I'm going to add something here, and something here. So half of negative 2 is negative 1. Squared is positive 1. Now I need to keep this equation equal, so I added 1, but out here it's a negative, so I actually subtracted 1. So instead of subtracting 1 out here, I'm going to add 1. Because I subtracted 1, then I added 1. So the vertex equation is y equals negative x, half of negative 2 is negative 1 squared plus 2. This is the vertex form. From here I can write the vertex, which is just, remember it's counterintuitive, 1, positive 2. The axis of symmetry is going to be x equals whatever the x in the vertex is. And now I've got a negative here, so now I know that it opens downwards. I'll just use a down arrow for that. On number 6, we're supposed to write the domain and range using interval notation. Well, the domain is just from negative infinity to positive infinity, and it never quite touches those, so I used round brackets. But the range is how low to how high. The lowest value in the range is negative infinity. And it doesn't ever touch negative infinity, so I use a round bracket. Now the highest it ever gets to is positive 2. And it actually touches, so I use a square bracket. So when I graph that thing, you start with the vertex at 1, 2. And now it's negative, so I'm going to go down 1 over 1, and then down 2 over 1. And then I can draw in this nice, smooth, quadratic curve. Like that. All right, one more. I want to do, let's do number 10. Y equals negative 2x squared minus 12x minus 24. So this time, I want to factor out a negative 2, because I don't want anything in front of that x squared. So now I'm going to have some parentheses, and I'm going to have that minus 24 outside, like that. Now I've got an x squared because I factored out the negative 2. Now negative 12 divided by negative 2, that's positive 6x. Now I know I'm going to add something there, and I'm going to do something out here as well. What am I going to do? Okay, well, half of 6 is 3. 3 squared is 9. That's a perfect square trinomial now. So I added 9 here, but 9 times negative 2, I actually subtracted 18. So to balance that out, I need to add 18. 9 times negative 2 is negative 18. So if you subtract 18, then you have to add 18 to keep it nice and balanced. So y equals, keep the negative 2. And we've got x, let's see, half of 6 is positive 3, x plus 3 squared. Negative 24 plus 18 is negative 6. So I'm ready to write the vertex. Remember, inside the parentheses is counterintuitive, so that's going to be negative 3, negative 6. The axis of symmetry is x equals whatever the vertex x is, negative 3. And then it's a negative, so it's going to open downwards. All right, so this is the weird domain and range. We're going to do the domain and range using set notation. So in set notation, you actually have to say two things. First, you have to say that x is a real number. This says x is a real number. And then put a comma, and it's the same as inequality form. So from negative infinity, x is less than and positive infinity. Same thing with the range. Fancy bracket. Y is a real number. And this time, let's see, it opens downwards and it goes up to -6. So y is less than or equal to -6. So now I'm going to want to graph this thing. Start at the vertex, which is -3, -1, 2, 3, 4, 5, 6. And so there's a 2 in front of the equation, so I'm going to go down 2 over 1. Like that. That's it. That's how you complete the square to graph. Thanks for watching. I hope it was useful.